In this demonstration, we'll take a look at the use of dynamic memory allocation with a class file. We'll see an example of how we dynamically allocate memory for an object that we create in our code, and then how the destructor plays a part in the releasing of the memory resources when we delete that object in our code itself. So what I've done is recreated the person class here, and we can see that we have our three private member variables for first name, last name, and age. We have our three constructors. We have a single destructor, and then of course we've encapsulated our private member variables with setters and getters, and then we have our say hello function here at the end. Now we're not making use of everything within this class for the example as we go through this demonstration, because again it's just designed to give you an idea of how the destructor plays a part in your class when we delete the object in memory. So the only thing that I've really changed in our person class, everything here is the same. We have our default constructor, the 2-argument constructor, the 3-argument constructor, and of course our setters and getters. But the only thing really that's different is this line of code that I've written in the destructor itself. Now this is not something you typically do in your code, but for demonstration purposes, I put this output statement here so that we can see in the console window when the destructor is actually called. So we look at our driver program for the purpose of testing. We see that we will create a person object called P1, and it's a pointer variable. So we use the new keyword to instantiate memory for this object. We use the 3-argument constructor to build that object in memory. And then what we will do is issue a statement here just to show that we're actually dealing with some data for the P1 object that we've created, and we'll return the first name that we set in the constructor. And then just to show that it does actually exist in memory, we will output a memory address which has been assigned to that variable. And again, take note that we're using the address of operator here. And then once we've completed that, we will basically destroy the object, indicating to the operating system that we're finished with the object and it can take that memory back. And we do so by calling the delete keyword. Now you may remember this from earlier demonstrations where we showed deleting objects through dynamic memory allocation that were just value references. And in this case we're dealing with a reference variable or a class. So a destructor will actually be called once this delete statement is executed. So let's go ahead and run this code and see what happens. And we wait for it to compile, and the command window pops up, and in our console window we can see that we did indeed assign first name Tom, and that's what we pulled back out with the get first name parameter in that line of code right here. Then we asked for the memory address of P1, and we've been given a memory address. In this case it ends in FE28. And then once we call the delete keyword, we can see that the code within that destructor was actually executed, and we output the person destructor called statement to tell us that the destructor was actually called. Now just by way of an example, and again proving how dynamic memory allocation works, I'll press the enter key to end that, and then I'll execute the code one more time, and you notice that the memory address now has changed. So we've dynamically assigned memory for each one of those objects that we created, but our application is not continuing to consume that memory because our destructor has been called in each instance. So again, a relatively quick short demonstration just showing how we can dynamically allocate memory for our objects in our code when we create new instances of the class files that we've created. And through the use of the destructor, we saw that this simple line told us that the destructor was called simply by us initiating a delete statement on that particular object, and the memory was released back to the operating system.